We have spent so many hours and so many samples and so many test revs, spokes by themselves, wheels by themselves, trying to come at it from how do we show they can't work to prove to ourselves that they can, right? And I think that's different from, hey, these are absolutely gonna work, because you're not challenging yourselves differently. Being able to partner with Aris Composites on an all new composite spoke and really bringing just new technology to the industry and a new way of thinking about it, and making a spoke that isn't a detriment to aerodynamics, and really like working as a team to say, hey, we need the strength, we want the weight reduction, the vibration, and the handling, but man, this thing still needs to be freaking fast, and really pushing each other to make a great aerodynamic spoke that, just elevates the wheel beyond what we ever could have thought.
There's so much potential for carbon fiber composites being used in many more areas than you see it, but the limitation is having a technology that can get you both to scale and to quality. So we started with molding as the backbone to it. Molding's not new, it's been around for 100 years with injection molding, but it's largely been plastic-based materials. But we can take it from plastic level performance to stronger than metal performance. There's a huge opportunity, and that's how we started it. I found Bert at a university. He was in South Dakota doing research on thermoplastic material pre-pregging. So that's the process of you take dry fiber, you take plastic, and you combine them. And at the time, we were saying we don't want to be a materials company. We actually want to be a product company. So let's find materials companies that can make thermoplastic composites in a form we can use like a rod. That way we can shape it, get the alignment of fiber, get the performance. But we had kind of two spectrums. One, the quality was really poor, inconsistent, like not usable. We need a better solution. I mean, everything seems easy when you start. We looked at how we're making material, and the material we're making is almost like the exact shape, at least in diameter, of a spoke.
When we started making progress on our spokes, right, our first call was back to Specialized, because there was kind of such an honest interest in the name of performance. The engineering team obviously had been thinking and evaluating other spokes out there, and I think our ability to produce high performance composite parts, our company, kind of our ethos, and just being able to be here and work together, being able to drive between offices, it makes the logistics of building that relationship pretty straightforward.
We say, okay, well, can we use our material? All we need to do is put some end fittings on, ta-da, we have a spoke. What we really underestimated, what became now a core part of our IP, was how do you attach the carbon fiber to the metal end fitting?
We tackle materials, process, and the equipment all at the same time. Most composites manufacturing companies will do one or maybe two of those things. By controlling all three of those things, we can get every little bit of performance out of that spoke that we wouldn't be able to do if we were compromising, waiting for someone else to design an aspect of it. For us, spoke manufacturing starts with the raw material. So we have a proprietary pre-pregging machine that combines polymer with carbon fibers into a toe preg or a rod. And that rod is the kind of base thing that we turn into a spoke. From that pre-pregger, we go to the compression molding step. We have a custom metal tool that has the arrow shape cut into the steel that presses and heats and flows the polymer, the plastic, to create that arrow shape. Once we mold the spoke, we send it over to the fitting attachment method. Once you start with FAM, you start with cutting the shaft to length, thread the metal ends on, and then you go into what we call the flaring step. It very carefully spreads all of those carbon fibers out without damaging or kinking any of them, so that then we can evenly load them and form a nice joint all the way around. In order to make a spoke with just a glue, if you were just to glue the metal end fittings on, the end fittings would be huge, and that would mean heavy and low performance. So in order to get the mass of the end fitting down, we had to use a mechanical tapered interlock. The harpoon is really where that interlock is formed. We add material inside of the flare, add heat, and then form it inside the end fitting. And that forms a taper, kind of like putting an axe head on an axe handle. Final step is to put the shaft into the preloader, where we very carefully apply a force to seat the joint, effectively set up a normal force inside the end fitting that allows friction to hold the joint together.
Carbon spokes are absolutely the future, and for us, it's really important to partner with the best company, the best technology for that, and to partner and elevate the product together. And really this co-development of this new spoke together, Revolve by Aris is just powerful, and I think it's going to give our riders a huge advantage that no one else has.